All right, so let's pick up where we left off last time. A couple of things. I had some folks email me. I think there's 3 or 4 of you that are running Chromebooks. Um, that's going to continue to be an issue throughout computer science. We can come up with a solution for it now, but that's not going to carry you through a CS degree program. So you're going to want to look at getting something else. There is a way actually to install Linux on a Chromebook, which would not as a virtual machine, but actually have it running Linux. I looked at a couple of tutorials for it, so if you wanted to tackle that, that would probably give you some runway. But just in general, Chromebooks are they're enough, let's say, for like high school or something, but they're not going to give you the flexibility to run a lot of the software that we're going to be using throughout your 4 years here. So you might want to start thinking about what that looks like moving forward. In the meantime, we're going to try to get Raspbian on a couple of our lab machines so that if you are having some issues, you have a place you can go to work on it. I know some of you were trying to do it with your Raspberry Pi. There is a, so here, let me just quickly, so if you, Raspberry Pi, call it without monitor, something like that. So there's some tutorials out there where you could actually use your Raspberry Pi on your computer without a monitor. So follow one of those, but the short version of it is this. You set your Mac or your PC up, and I assume this would work on Chromebook, although I have not used one, so I'm not sure if this is something that you can do on there. But you set it to share your internet connection. And so, on a Mac here, if I go to settings, sharing, where's my sharing? I can go and click on internet sharing over here. And if I click on that, it's going to ask me, where do I want to share it across? So for me, I only have an Ethernet port through this USB adapter, so I would choose that. I'm just going to cancel it because I don't want that on right now. But what that'll do is it'll share whatever your wireless is on your computer with something else that's connected. You actually might get an error message saying, if you're on FalconNet, saying you're not allowed to share that because it's like an enterprise thing, but I think this would still work for the purposes of this. So what happens is when you have internet sharing turned on, now you can plug your Raspberry Pi into the Ethernet on your computer and it will get a IP address. And then from there, you can actually get to it. You can get an SSH client and you would SSH, I think it's pi at raspbian.local. That's what the name of your Raspberry Pi will be. And that will log into the Raspberry Pi via SSH. Once you have that, you can do a search for something called headless VNC. So if you do Raspberry Pi headless VNC, this will tell you how to, you'll use SSH to start up VNC server. And then once you have that, you can get VNC viewer for your laptop and remote into your Raspberry Pi and use it as if it's a full functioning Linux thing remotely, running your virtual machine on the Raspberry Pi, not requiring an external monitor, an external keyboard. It's a little bit of a geeky setup, but it does work. I've done it on mine before. So if you want to either actually send me an email and I can get you connected with our graduate assistant and he can help you get that set up if you want some assistance with that. But that would be a solution in the short term if you're having issues with the virtual machine on your computer. But like I said, we'll have a couple of machines set up with Raspbian on it, hopefully this week. I have my grad assistant working on it today. I think what we're going to do as a starting point is put them down in the makerspace in the plaster building, the thing that has all the 3D printers. So if you're going to need access to that, send me a email today with or message me on Slack, either one, with your phone number, and I'll contact them to get you added to the swipe on that door so you can get in and use the iMacs in that room for doing the Raspberry Pi virtual machine. So that's our short-term solution, but longer term, if you have a Chromebook, you're going to want to look at moving away from that. I think the university is starting a laptop program in the fall, so I'm guessing that will, through your financial aid and stuff, you'll also be able to get a laptop. I'm not sure how that's going to work, but that's a thing where they're going to require everybody coming in to have a laptop of some vintage or something like that. Okay, so at the end of last class, we started talking about size conversion and number conversion, and we're going to hopefully get to this today, but I want to take a few minutes and talk about a couple of Python things that'll prepare you for the homework that's due on Wednesday and on Friday, because we're dragging behind about a half a class. Hopefully everybody saw on Slack that this coming Wednesday, I think it's this coming Wednesday, right? We will not have class. I'm at a conference in downtown Milwaukee on artificial intelligence, so I will not be here for class, but homework will still be due. I'll cover everything we're going to need to cover for today and for Wednesday's homework as well as Friday's homework today, so you have the necessary background. Sound good? So don't show up on Wednesday for class because I won't be here. Well, you can show up if you want, but don't expect to get a whole lot out of it. Maybe show up and work in groups if you want to work on your homework. All right. So, let me come over here. So in the book, I think I mentioned start reading, chapter 1 into chapter 2. All right, so you're going to want to start doing that at a more accelerated pace leading up to these next two assignments. You're going to start noticing pretty quickly here that we're going to be scaling up our programming fast. So I'm going to go through Python basics some today, but we're not going to deal with a lot of this fluff here. I'm going to kind of introduce types to you. Last time, remember, we talked about primitive types. I think it's here in Python basics, isn't it? No, it must be on the next thing. But I'm going to introduce some tools to you that we have access to for accomplishing some things. Oh, it had to be on the previous one. Maybe I just scrolled past it. I did scroll past it. Okay, so what I'm going to do is we're going to go into Raspbian. And again, if you are looking at how to accomplish this, once you're in Raspbian, hit the Raspberry, hit Programming, go down to Thonny, Python IDE. That's the one I've been demoing with. There might be some better ones in there or whatever, but whatever. All right, so we're going to experiment with a couple of things out here that will be beneficial for you for your homework on Wednesday and Friday. You're going to be working on something called FizzBuzz, which is a kind of a famous beginner problem that has you asking some questions about a number and determining whether or not you should output a fizz, a buzz, or FizzBuzz. So depending on how you test the number and what the criteria it meets, you would output one of those three outputs or the number itself. And that'll make sense once you go and look at it, but I'm going to show you all the tools you'll need for accomplishing that. All right, so we're going to look at some of the operators here. Now, these guys down here should make plenty of sense, right? Division, multiplication, subtraction, addition. These aren't life-changing type things. But we are going to talk about division for a few minutes. This is something that actually is different than a lot of programming languages. So for instance, if I was in a language like C, C++, Java, and I said 5 divided by 2, this would be integer division in those languages, which would give me a 2. It would truncate. Okay? In Python, it gives me a 2.5. Okay, so in Python, the default division operator does floating point division. If I want to get integer division, I would say 5 /2. That would give me the floor of the division. So even if something was 2.9, it would give me a 2. Okay? So what, like 7 divided by 3? That's going to be a bad one anyways. I would have to do like a 6.1 divided by 3, something like that, to give me some number that's closer. I can't. Oh, actually, I think I could right-click and clear, and that puts me back up there. Okay. So in any case, if you want to get integer division, dividing some number by another number and getting the whole number result, you would use the double slash. This goes back to like 3rd grade math. Now the opposite side of that is the modulus operator. So remember long division in 3rd grade? Where you had some number, remainder 1, some number, remainder 2, something like that. So if we had some value, I'm going to start actually here with this stuff. So for instance, 5 divided by 2, floating point numbers, we would say that's 2.5. But in 3rd grade math, we would say this is 2 remainder 1. So 2 goes into 5 2 whole times. 2 times 2 is 4 with 1 left over. All right, so to get that, we would say 5 divide 2. This would give us the 2. And then 5 mod 2 would give us the 1. This is the modulus operator. It gives us the remainder of an integer division. All right, those are going to be extremely important tools you'll need for Wednesday and Friday. Okay, another thing that's fairly common is you want to take something to a power. So 5 to the 2nd power. All right, you might be encouraged to write it that way because that is, kind of a common way of writing something to a power, right? Okay, what should 5 squared be? 25. But of course, we get a 7. Now, what's interesting here is you might look at that and say, well, it didn't give me an error. Then the question is why did it not give me the error? In most modern programming languages, that caret is not the power operator. It is what's called the bitwise exclusive OR character. All right, and let me just show you really quickly what I mean by that so you see where we got that 7. It's actually related to this number conversion thing we're going to be talking about, so I'm not going to get into the details of this too quickly right now. But if I say 5 caret 2, that's going to give me a 7. Now the question is why did it give me a 7? Well, what it does is this is called a bitwise exclusive OR operator, which you will very, very, very rarely ever use as a developer. Okay, so what I'm telling you right now is going to be something that's relatively trivia knowledge. I'm not going to test you over it, but maybe store it somewhere in the back of your head in case you ever feel like you want to use the caret symbol to do something. It's not going to give you the result you want, but the problem is for beginning programmers is that it does give you a result instead of an error. And that can become problematic because now you have a program that doesn't do what you expected it to do, but it's not screaming at you, you just get bad math. All right, let me tell you why it gives me a 7. So what I'm going to do is I'm going to write the binary version of the number 5. So this is the binary version of the number 5. This is 1 in the 1's place, 0 in the 2's place, 1 in the 4's place. 4 plus 1 is 5. All right, and if you aren't used to dealing with binary, that's fine. We're going to cover it when we get to this slide. Okay, I'm just showing you the punchline here because I want to prepare you for the stuff this week. So 5, this is 5 in binary. 2 is, I'm going to write it as a 3-bit number again, so this is 0, 1, 0. So this is 0 in the 1's place, 1 in the 2's place, 0 in the 4's place, so that's a 2. All right, now the way the exclusive OR operator works, any exclusive OR, says so that your collection is ANDs, ORs, exclusive OR. So an AND says that both bits need to be a 1 in order for the resulting bit to be a 1. And in general say a true and a true is true. A true and a false is false. A false and a true is false. And a false and a false is false. So in order for an AND to boil down to true, everything needs to be true. In order for an OR to boil down to true, either side or both sides must be true. So true or true, false or true, true or false. The only way an OR boils down to false is if both sides are false. So false or false. Now exclusive OR works a little differently. Exclusive OR says only one thing can be true, but not both. So true exclusive OR true is false because they're both true. True exclusive OR false is true. False exclusive OR true is true. False exclusive OR false is false. So only when exactly one thing is true does an exclusive OR boil down to true. And we'll cover those things again later, specifically ANDs and ORs. Like I said, we don't use exclusive ORs very much. But we are doing a bitwise exclusive OR here. So when I say bitwise, we do an exclusive OR between this bit right here and this bit right here. Then we do an exclusive OR between this bit right here and this bit right here. And we do an exclusive OR between this bit right here and this bit right here. And we said an exclusive OR says only one of the values is true. So in this case, 1 exclusive OR 0 is 1. Exactly one of them was a 1. 0 exclusive OR 1 is a 1. 1 exclusive OR 0 is a 1. That is the binary value 7. This is the 1's place, the 2's place, the 4's place. 4 plus 2 is 6, plus 1 is 7. That's where that 7 is coming from. Yeah.
What's even the point of having an operation like this?
Nothing for us right now. It's used heavily in like cryptography and network masking, things like that. So things that won't make sense to us right now, or at least aren't related to this class. There's plenty of mathy reasons for using bitwise stuff, but nothing related to, let's call it, general purpose programming. Very rarely, if ever, in your career are you going to use this, unless you go into a specialized field or something in security. And even then, you might only see this because you're going to be using the encryption tools. You might only see this when you learn about how that encryption algorithm actually works. You're probably just going to say, I want to use RSA or triple S to encrypt something, and magically it gives you the answer. And if you were to go and investigate the math behind that answer, you might find the use of a bitwise exclusive OR in there. Okay? So I am not going to test you over bitwise exclusive ORs. I just wanted to show you why we got a 7. Okay? Because this is one of those things that will drive beginning programmers nuts, because you want to write code and it either works or you get an error. And then one of the skills you're going to learn as a beginning programmer is how to debug those errors. And the first rule of thumb I'll tell you is when you get an error, read it, Read what the error says. Don't see the wall of red stuff and just assume, oh, I need to go make changes, and immediately go back to your code and just start manipulating things. Because then in the end, what do you have? You have a computer program that maybe works, but you have no idea why it works. You just tried every permutation of the math until it finally gave you a right answer. All right, so always make educated guesses when you make changes, but before you go and just haphazardly make a change, read the error message, because it will tell you, hopefully, a reasonable, it'll pinpoint you where the problem might be. I will say that sometimes error messages can read a bit like stereo instructions, and it is somewhat of a skill to get used to how, what a certain error message might mean. They read kind of weird. Sometimes it'll point to line 7, but for example, the actual error is on line 3. It just wasn't realized until line 7 as you're kind of going step by step through the code. So that'll be a skill that you're going to get through practice by putting in those reps. But always read the error messages. This is just one of those things that can be frustrating because it gives you a numeric answer, which is what you were expecting, but doesn't give you the numeric answer you were expecting. So that's why I wanted to show it. If you actually want to do 5 to the second power, you would say 5 double asterisk 2. That gives you your 25. And that's this guy right here. That's our exponent. Make some sense? All right. So you will find this little chart here in chapter 1 of the book helpful to remind you of these things. Multiplication, subtraction, and addition work as expected. Addition adds things. Subtraction subtracts things, so on and so forth. All right, so you do need to be a little careful with division because a lot of times in programming we do care about integer division versus floating point division. We want that whole stuff from 3rd grade. The long division sometimes can be helpful, and it's going to be very helpful in our homework for Wednesday and Friday. You're going to be using those two heavily. All right, questions about any of that stuff? Okay. So the next thing I'm going to talk about here, and remember we talked about how the way human beings solve problems is memory, asking questions, repetition, and I said 100% of programming languages will have facilities for those 3 things. I'm going to go ahead and introduce those things right now. So memory is equal to variables. Python is a loosely typed language, which means we do not have to define the kind of value that we intend to put into a variable. So to define a variable, the syntax for defining a variable is the var name equals the var value. So for instance, A is equal to 5. C is equal to hello. Something like that. D is equal to 3.14. A is equal to 5. Then if I were to print out A, I get the value of A. The interpreter here, the interactive one, also allows you to just put in A, and it'll resolve it for you and show you the value that's in there. C is equal to hello. There's the value stored inside that variable. All right, make some sense? Now, if I want to add those two together, remember A is 5, C is hello, and I say something like A plus C, we get the error message. Okay, this guy's telling me, unsupported operands for a string and an int. You cannot use the plus sign to add strings and ints. Now, the plus sign has 2 different meanings in most modern programming languages. It's addition when we are working with integers on both sides of the operator, and it's concatenation when we are working with strings. Now, this is where we have a little deviation with Python versus other modern languages. So Python requires strings on both sides of the plus to treat it as concatenation. This has something to do with the fact that it's an interpreted language, that there is this translator that's going through it during runtime and making some decisions. So as it's walking through that string, as it's walking through your expression rather, like hello plus 5, it hits the plus before it hits the 5. Right? So it's just going to make the assumption that since the first part of it was a string, it's expecting that second part to be a string because it's going to have to make that decision about the plus sign being concatenation instead of addition beforehand. Where if we were dealing with a compiled language, and we talked about compiled versus interpreted last time, right? Yeah. So if we're dealing with a compiled language, that decision about addition versus concatenation would have been made prior to us trying to run the program. All right? So Python requires strings on both sides. Languages like Java, C, C++, C#, these guys require at least one side to be a string to treat the plus as concatenation. That make sense? So if I were in a language like Java, A plus C here would have given me 5 hello. It would have glued those two things together. That's what concatenation does. Okay, concatenation says whatever's over here and whatever's over here, join them into a resulting string. So concatenation says glue two things together, creating a string. And then we'll just say at least one side needs to be a string regardless. And then we'll further clarify that for Python versus some other languages. This would be one of those little idiosyncrasies of certain languages versus another. How does concatenation work? Having said that, if I want to get that 5 hello, or the hello 5, depending on which one I put first, I can. I have a tool. Let me just... I still have A? Yep, okay. So what I can do is, we know A is an int. We know C is a string. I could say turn A into an integer, or rather turn A into a string. That'll give me the string 5. So now I can say string A concatenated with C, and that will give me 5 hello. For the plus sign to be treated as the concatenation operator, both sides need to be a string. So I need to make that integer a string. So we have a little tool called str. Just say str value. This guy converts value into a string. Make sense? That's what that guy does. Similarly, we have another tool called int that will turn value into an int. We do want to make sure that what we are trying to convert to an int makes sense. That is to say, what if I tried to say int of hello? as a human being, if I told you to take hello and convert that to an int, what would you expect the result to be? We don't know, but an error, some made up thing, whatever. We don't have an expectation of an actual output, right? You know, that doesn't make sense to turn hello into an int. So if I try to come out here, I think I can stretch this out up here. There we go. So if I say int of hello, it screams at me and says, int has to be a base 10 value. So it's yelling at me and saying, that's not a number thing. All right. Whereas if I say int 124, that'll now give me the number 124, which I can then do addition with. That make sense? All right, so we have a couple of tools. This guy juices this value into a number. I always think of it like that. You throw a string in there of a numeric type and it juices the number out of it. That's what the tool does. This guy will convert this value into a string. So for example, if I say the string version of 5, this will produce for me that. The string version of 3.14 will produce for me that. Now, if you're working in a language like Java, the go-to move for doing the same type of thing is working with the empty string and concatenating onto it a 5. So remember we mentioned a few minutes ago that in a language like Java, that plus sign is treated as the concatenation operator if at least one of the sides is a string, whereas Python requires both sides to be strings. So in Java, I can take the string that contains nothing, that is the empty string, and concatenate onto it a number, producing the empty string glued onto that number, which is the string of the number. Okay? So tools that you can use, so we don't necessarily need to convert things into strings in a lot of our strongly typed languages. But in loosely typed languages, it's pretty common, and for us, Python requires us to do that. Strongly typed languages, we can operate off of the empty string literal and just use concatenation to produce the string of it. All right, questions about those two tools? Think about that like running to Home Depot. We grab two tools off the shelf. One's called int, one's called string. The int one, I can drop something that is intable into it, and it'll shoot out the integer version of it. So if I give it the string version of a number, it'll give me the int version of it. Hence my made-up word intable. The other one, string, says, give me some value, and it will spit out the string version of that value. Another tool, you drop something into the top of it, it does its magic, and now you have a string version of it. These are two tools that will come in very handy as you're programming. Okay, so now you've added these tools into your toolbox. All right, so questions about variables and some of our operators, mathy stuff. Other things are going to come up as we go on, but this is a reasonable introduction to that stuff. Next thing, asking questions. We do this through conditionals. The syntax for conditionals in Python is if. There's another type of conditional as well, but we're just going to focus on ifs right now. So it's going to be if, then something called a Boolean expression, colon, then you kick it down, and then body of the if. All right, we'll see some examples of this. So Python pays a lot of attention, actually requires indentation. So in Python, if we have an if expression, anything that we want to be part of that question. So if something is true, do some stuff. Any of that stuff that we want to do as a result of a positive answer to a question needs to be indented underneath that if. If it's not part of the if. All right. Now I've mentioned something here called a Boolean expression. What's a Boolean expression? Okay, well, Boolean values are true and false. Those are our Boolean values. True or false, on or off, 1 or 0. Make sense? All right, so those are our Boolean values. We've messed with that a little bit today when we looked at our exclusive or bitwise example. So a Boolean expression is any expression that boils down to a single value of true or false. Keep in mind that Boolean expressions don't have to look like they involve trues and falses. So for instance, if I say 5 less than 4, is 5 less than 4? It's not. 5 is a bigger number than 4. So this would boil down to a false. That's a Boolean expression. Make sense? And we have all of our things. We have the less than or equal to, greater than or equal to, not equal to. So we have the exclamation point is the not operator. Let's see, is it not? Was it? Oh, this is running it at the command line. You know what? I think it's actually this. Yeah. But not equal to is a thing. So 5 not equal to 4 is true. All right, so in a lot of languages, the exclamation point is the operator that's used for not always, all the time rather. So this guy is an operator not equal to. So this is the numeric Boolean operator for this. Is it true that 5 is not equal to 4? That's a true statement. But I can also say not 5 less than 4, let's say. 5 less than 4, is that still showing up on the screen? 5 less than 4 is false. 5 is not less than 4. But not flips the Boolean to the other one. That makes it a true. So not true is false, not false is true. All right, so the not function, let's say, creates the alternative to the Boolean. So this is another tool from Home Depot. This returns the opposite Boolean from the result of Boolean expression. Okay, so right now when we see these things like not, int, string, these are functions, but we should think of these as tools that are now in our toolbox. We don't have to worry about how it accomplishes it. We just know that if I drop something in here that is some Boolean expression, not will give me the alternative Boolean value. Keeping in mind that a Boolean expression is any expression that boils down to a single value of true or false. So anything I put in here will boil down to a single value of true or false. Not will make it boil down to the other one. Make sense? Okay. You don't have to worry about when you might use that tool. Just throw it in your toolbox right now, and at some point in time, you might find a use for that tool, and you'll pull it out, dust it off, and use it then. Okay? Probably not something that's super, super commonly used, but certainly used way more often than exclusive OR. And certainly more common than the bitwise exclusive OR. All right. So, questions about Boolean expressions? Typically, the Boolean expressions we start off with are things like something less than something else, greater than, not equal to, the mathematical Boolean operators. Out of curiosity, let's say I have a value A and I set it equal to 5. And I want to know if A is, and actually let me, I'm going to go ahead and write this up here just so we can run it at once. So I have a variable A, I'm going to set it equal to 5. And I want to ask the question, if something is true, print out even number. I want to ask a question in here that determines whether A is an even number or not. What does it mean for a number to be even? Go ahead.
Evenly divisible by 2.
Okay, evenly divisible by 2. How do we check that based on what we've learned today? The tools that we have in our toolbox that we've collected today, how do I ask if a number, go ahead.
Do like the mod divided, like the mod 2, and then see if it's 0.
Okay, because we're looking at the remainder, right? So I'm going to say if A mod 2, that is when I take A and I divide it by 2 and I look at the remainder of that, if that guy is equivalent to, double equal sign is the equivalence operator. Single equal sign is the assignment operator. So A equal 5 returns true if A is 5. Let me indent that. A equals 5 assigns the value of 5 to a variable named A. Make sense? Common mistake for beginning programmers. Double equal sign is equivalence, single equal sign is assignment. We use that to give values to variables. All right, so if I take A, I divide it by 2, and I look at the remainder, what will the remainder be if A is evenly divisible by 2?
0.
Be 0. That means that A mod 2 has a remainder of 0. That means it must be an even number. Oh, do I need to save it first? Oh, it's not an even number. That's why it's not outputting anything. Good example. All right, so A is 5. 5 is an odd number, right? My program says only do this if this statement is true. A boils down to the value 5. 5 mod 2 is a 1. Right? Is 1 equal to 0? It's not, so we will not do this. I can optionally have an else and print odd number. Now this guy will have a output of odd number.
How would you do like an if-else statement?
Well, you mean like this, or you mean having like a third thing?
Like a third.
All right, so we have something called elif.
Okay.
I don't know. Let's say A less than 100. I guess this means something. Something like that. Otherwise, we'll get to the odd number thing there. But actually, this is a good point because in an if-else structure, only one of these will get hit. Okay, so this first one says, is A an even number? It's not. A is 5, it's an odd number, so this will be false. We'll drop down to the next thing, which happens to be, our question is, well, is it less than 100? Which has nothing to do with even or oddness, but we're asking the question anyways. In this case, it's true. 5 is less than 100. We'll print out, I guess this means something. Noticing that we never hit this last line of it's an odd number because only one of them can fire. We just go through an if-else structure until we hit a true. That makes sense? So this is equivalent to other languages. You might see something that says else if, like that. In fact, I think that might even work. No. You can make it work by doing that. And then this else no longer makes sense. So this is an else that happens to have an if inside of it. But if you want it to be part of the decision-making structure, you would say else if this is true, do this stuff. And notice that first of all, this program indents for us. The indentation is usually people use a tab. It doesn't have to be, it just has to be equal. So anything I want to have happen underneath this print has to be indented within that print. So inside the else, I'm just going to call this an else for right now. So else says otherwise. Outside of the else. So even though this guy comes on the very next line, this dude right here is not part of this if-else structure. So it will happen every single time, regardless of what our answer up here is. So here's our else to that guy. If I change A to be an even number and I run it again, it'll print out even number, then it'll print out LOL, and it'll still print out outside of the else because that guy is not part of that else structure. Go ahead.
So say you wanted to first of all determine if the number was even or odd and then say if it was less than 100 or not, would you have to make an entirely separate if statement for that second condition?
No, so you want to say if it's even and A is less than 100, something like that. Then we could say it's an even number, but if I change this to 4,000, which is also an even number, we get to the I guess this means something. So you can use ands and ors to string together Boolean expressions. All right, last thing, just so you have everything that you need for your homework, I'll quickly show you a loop. So we're going to say for I in range 0 to 100. I think I actually showed this last time, but we'll just say print I. So this will take I on a voyage where the first time through it's a 0, then it's a 1, then it's a 2, then it's a 3, all the way up to, but not including this last value. So this will do repetition. This is our third thing there, repetition. All right, makes sense? All right, I think you have everything you'll need to do your homework for Wednesday as well as Friday. We'll come back and we'll do our number conversion stuff then. Sorry about Wednesday. The conference kind of snuck up on me. Sure.
Is there a way to like copy